All right, let's get into it. We're going to build your very own mathematical toolbox. The idea here is to learn how to take apart these big, complex expressions and really see what makes them tick.
Okay, so check this out. On the left, you've got this expression 6x squared minus 11x minus 10. Kind of looks like a jumbled mess, right? But then look over on the right. 2x minus 5 times 3x plus 2. So much cleaner. Now here's the crazy part. They're exactly the same thing, but the one on the right is way easier to work with. So the million-dollar question is, how in the world do we get from that mess on the left to the neat package on the right?
Well, that whole process is called factorization. And honestly, it's kind of like being a math detective. You know, you're given the finished cake, and your job is to figure out the original ingredients. The flour, the sugar, the eggs. It's all about breaking something down into its most basic, fundamental parts.
All right, tool number one for our toolbox. This is the big one, the most important one you've got, the common factor. Seriously, this is your Swiss Army knife. It's the first thing you should always look for. It might seem simple, but trust me, it is super powerful. And the best part? It's basically a two-step deal. Step one, you just scan all the pieces of your expression and find the biggest thing they all have in common. Could be a number, could be a letter, whatever. Step two, you just pull that common piece out front and then write down whatever's left over inside some parentheses. That's it.
Okay, let's look at a real example. We've got 3x squared y minus 6xy squared plus 9xy. Now let's play detective. What do they all share? Well, 3, 6, and 9, they're all divisible by 3. Cool. They all have at least one x, and they all have at least one y. So, boom, our greatest common factor is 3xy. We just yank that out to the front, and suddenly, what's left inside is way simpler.
All right, your turn. Have a look at this one. Negative 7x squared minus 14y. What's the biggest thing you can pull out of both of those terms? I'll give you a hint. Pay close attention to the minus signs. Take a second. See if you can find the right answer in that list.
Okay, but what if you look at an expression and there's nothing that all the terms share? Do we just throw our hands up and quit? No way. This is where we need our second tool. It's called factorization by grouping. This is your go-to move when things don't look so obvious at first glance. So the whole trick with grouping is to be a little clever. You look at your terms, maybe move them around a bit, and then you split them into little teams, usually pairs. The goal is to find a common factor in each little team. And if you do it right, something really cool happens. A brand new common factor appears across the board.
This example here is perfect. See? ax minus bx plus ay minus by. Nothing is common to all four terms. But what if we group the first two together and the last two together? From the first pair, we can pull out an x. From the second, we can pull out a y. And then, look, it's like magic. Suddenly, both chunks have an a minus b in them. That's our new common factor, and we can just pull it right out.
Okay, let's try another one. Now this one, a squared plus bc plus ab plus ac, it looks a little weird. The terms are all mixed up. But remember, we can rearrange things. What if you put the terms with a next to each other and the others next to each other? Give it a shot. If you group them smartly, the path to the answer just kind of opens right up.
Okay, time to pull out a specialty tool from the toolbox. I'm telling you, being able to spot patterns in math is like having a superpower. And this next one, it's a total classic. It's a shortcut that's going to save you so much time and effort. You just need to train your eyes to look for it.
It's called the difference of two squares, and it is so elegant. A squared minus b squared equals a plus b times a minus b. That's it. Anytime you see something squared minus another thing squared, you can immediately, without thinking, break it down into a plus b times a minus b. And you might wonder why that works, right? Well, if you multiply it back out, you get a positive ab and a negative ab in the middle, and they just poof, they cancel each other out, leaving you right back where you started. It's so cool.
So on the left, you see a pretty straightforward example. 25a squared is just 5a squared, and 36b squared is 6b squared. Easy. But now, look at the example on the right. This is where this tool really shines. Your a and b aren't just single letters anymore. They're whole expressions in parentheses. But you know what? The pattern doesn't care. It's still just something squared minus something else squared. The rule works exactly the same way. How awesome is that? Okay, so let's put it to the test. Look at this one. A plus 2b squared minus a squared. Don't let those extra brackets throw you off. Just ask yourself, what is the first thing being squared? And what is the second thing being squared? Once you've got your a and b for the pattern, just plug them in and see what happens when you clean it up.
All right, so our toolbox is looking pretty good. We've got 3 awesome tools in there now: finding the common factor, using grouping, and spotting the difference of 2 squares. So to make this all super practical, let's put it together in a quick checklist you can use every single time.
Now this is maybe the most important takeaway. The order here is crucial. You have to follow it. Step 1 is not optional. You always, and I mean always, look for a common factor first. Why? Because pulling something out at the very beginning can make the rest of the problem shrink down, sometimes making it so much easier that the next step just jumps right out at you.
So there you have it. You've got the tools now to break these expressions down into their basic parts. And this isn't just some random math puzzle, you know? This is a fundamental skill. It's what's going to let you solve way more complicated equations later on. It's how you simplify tricky fractions. Really, it's how you start to understand what algebra is all about. Because by learning how to take things apart, you're really getting ready to build something much